Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is bottom view of binary tree. So this question, in this question we have to print the bottom view. So if we will stand beneath this tree, then the view that we will get, uh, the nodes that we will able to see from there, we have to store them into an array list and return that. So this question is quite similar to the question that we had solved yesterday, which is top view of binary tree. So I would suggest that go and solve that question first, and you just have to change something in there, and we will able to solve this question as well. So let's see how we can modify that code and so able to solve this question as well. So in that question, what we had done, we suppose this is a tree. This is 28. Uh, let's draw it. 28, 22, 5, 3, 4, 25, 10 and 14. So 25, and for 3 it is 10, and for 4 this is 10, and for 4 it is 14. Okay, so now what we had to do, so in that question what we had done, uh, we will for each first we have initialized an horizontal distance of this current node with 0, because it is 0 from the distance of this node from itself is 0. Now if we will move on the left side, we will be decrementing this horizontal distance by 1 and incrementing if we will move on the right side. And also I had told you that we can use number line approach in that question. So now how we can modify for this, we can simply what so each unique distance for each unique distance for each horizontal unique distance, we will be adding that into a hash map, and we will be adding the first element, which will like suppose for -1, for 0 we have encountered 20, so we will be adding this 20. But in this approach what we will do, instead of storing the first element which we will be getting for a certain horizontal distance, we will be storing the last element. Suppose suppose we will get 20 for 0 for this node, and we will be get and the last element for that we will be getting 0, suppose is this, then we will be adding this instead of this. And this approach this approach allow us to store all the element which we will be getting, which we will able to see from the bottom. So if you try to verify this, so this 5 is the first unique distance that we will get, that is -2. This is 0, -1 and -2. And this 3 we will not able to see from the bottom. So, and you can verify that this also, that this unique distance is not the first one, is not the last one. This is somehow between the range. So this 10, this 10 that we will encounter, this is the last element for this given horizontal distance, and this element is also the last element for this given horizontal distance, and for this 25 also the same. So this is the approach, guys, we can use. Now what we can modify in the previous code that we had done. So instead of adding the first element for a certain horizontal distance, we have to add the last one. So instead of checking this condition, if our hash map contains, we don't have to check this condition at all. We can directly, for each node, we can directly put it into the tree map, and this will overwrite the certain unique distance, suppose -1, again and again, until and unless we will reach the last node, which will be giving us this certain distance. So let's see how we can code this out. There you will get a good idea what I had just explained. So we will be coding out the same, just what we had done in the level order, what we had done in the top view binary tree. So we will be using here also the level order approach. So if root is equals to null, so this is the case if we have given the null root, so we will be returning a new array list. So new array list of integer. Now after doing this, what we have to do, we have to make two queues and a tree map. So queue of node, queue of node is queue is equals to new linked list. This should be or just make it blank. Now let's make another queue of integer. So let's capitalize it. This should be horizontal distance is equals to new linked list. Now we have to make a tree map of integer and integer. Let's name it as tm is equals to new tree map. Now what we have to do, we have to make an array list as well, which we have to return. So array list of integer result is equals to new array list. Close it as well. Now let's try to put the first root node in the queue. So queue dot add root, and after that let's add its horizontal distance as well. So hd dot add, and it will be 0. Now let's perform the same thing that we had done in the level order traversal. So if q dot, let's make a not sign as well. So q dot is empty. So until and unless it will become false, we will be running this while loop. Now we will be polling out the current node. So node current is equal to q dot poll. Now after this, we have to poll out the horizontal distance of it as well. So int int let's make it as distance is equals to hd dot poll. Now we don't have to check for the condition that we had done in the top view. We just have to put again and again. So tm dot put distance comma current dot data. So now we just have to call for the left and right child and add that into the queue as well. So if current dot left does not equals to null, so in this case what we have to do, we have to push that into the queue. So queue dot add current dot left, and let's add the horizontal distance as well. So hd dot add distance -1. So this is left side, so we have to decrement the horizontal distance. Now let's copy paste it, and this should be current dot right, and this should be current dot right, and distance +1. Now what we have to do, we just have to, or after this while loop will get over, we will be having every last unique distance stored into a hash tree map. Now let's traverse into the tree map as well. So for int key into our tm dot key set. Now we just have to add this. So al dot add tm dot get key, and after this we just have to return a array list. Now let's try to run this code. Let's see if it will work or not. Okay, so this should be not al. This is a muscle memory, sorry guys. So let's see, let's try to submit this as well. So all the test cases have been processed. So thank you. See you in the next video. Bye.